All right, so our last video for 10.7 is another inscribed polygon. We are told that it's a parallelogram inscribed in circle O, so that means that because it's a parallelogram, we know that it is a rectangle. That was one of our theorems. And then they gave us some information, so let's go ahead and fill in what we know about our circle. We know that AB is 14. So this is 14, and then BC is 48. This picture is not drawn to scale at all, but that's okay. And then what it says is find the perimeter of triangle BCO. So BCO is this triangle right here. So we know one of our side lengths is 48. We basically have to get these other two sides so that we can add them all together to find the perimeter. So what we're going to do is we're going to kind of backtrack a little bit, look at the bigger picture, and work into that smaller triangle. So bigger than that small triangle, we know 14 and we know 48, and that is a triangle if you connect to AC that we can work with. I'll go ahead and redraw that over here. It is a right triangle because this is a rectangle. We know that this is 14, this is 48. Can we find our missing side? Well, of course we can. We have a couple ways to do it. You could use Pythagorean theorem. You could try your triples. I'm a fan of the triples because it saves work if you can. 14 and 48 can be divided by 2, so I'm going to write down divide by 2 and circle it so I don't forget that I'm dividing these by 2 to get 7 and 24. And for those of you that are using your triples, you'll recognize, oh yeah, that's a 7, 24, 25 triple. Anytime that you're using a triple, make sure you write that down for me because there's not a whole lot of work to show, and that's just your way of communicating, hey, the reason I didn't show you any work is because I used this triple right here, okay? All right, so that makes this 25. However, don't forget, because we divided by 2, we have to take that 25 and multiply it by 2. So really, this length is 50. So over in the circle, this whole thing is 50. All right, well, in a rectangle, when you have a diagonal like this, and you can kind of see it's, if I were to draw DB, they're intersecting at the center right there. These two sides are bisected by this BD, meaning that they are congruent. So that means that if the whole thing is 50, we've got 25 and 25. And then another fun fact about rectangles from last trimester is the diagonals actually are congruent. So I can go ahead and draw in, this is going to start to get messy, but this whole thing right here is also 50, meaning we've got 25 and 25. So at this point you can see we do have all the information we need for finding the perimeter of our BCO triangle. I'll redraw it over here. Here's BCO, and we knew that BC was 48, and then we got these each to be 25, and the question just asked for the perimeter. So all we're going to do is say perimeter equals 25 plus 25 plus 48. And in the end, our final answer is 98. And then does this have a unit associated to it? Just kind of double checking the problem. It does not, so I'm okay to leave it as 98. I'm going to go ahead and put units though, just because if this was an area problem, I would have to have that squared. And I just want to remind you guys that perimeter, you do not square your unit. It just stays the same.